Hi all, I'm Hazera Begam from Cybersecurity Department in St. Peter's Engineering College. Okay. Today I'm explaining about CPU scheduling algorithm from operating system subject. Okay. So CPU scheduling algorithm, why we need to learn about this algorithm means for multi-programming. Yes, here we are having ready queue. This ready queue lies on RAM actually. Okay, so in that RAM we are executing multiple programs at a time. So how this CPU will be execute all those multiple programs, okay, which basis it will be executed means. So here we are having in ready queue, for example, P0, P1, P2 and P3. Okay, so here we are having, for example, 4 processes we are having now. So in that 4 processes, how these 4 processes will be CPU is executing. So we are using here CPU scheduling algorithm. So on the ready queue we are having 4 processes, that is multiple processes. So multiple process, which basis these processes will be executing means, that is CPU scheduling algorithm we are using here. So here in the CPU scheduling algorithm we are having 2 types of algorithm, that is preemptive and non-preemptive. Yes, first we have to know what is preemptive, what is non-preemptive. Preemptive means once the process is executing, once a process is executing means it will be halting, means process will be forcefully halting here. Okay, so for example, in the class we are having 5 students. Okay, in that class I am having 5 students and every student is having 5 problems. So what I am doing, first student came, he is asking questions, so I am solving 2 problems. Next one more student came, he is a topper student, so I am giving priority to him. Okay, first student I have solved 2 problems, and another student, some topper came, I have given the priority to him and I am solving his problems. Means here what happened, first student problem I have not solved, I halted him and I am solving other student problem. So preemptive means one process came, it is executing in ready queue, it came to running state, that P1 process came to ready queue to running state, it is executing. So P2 came, at that same time P2 came to running state. So what happened, CPU will be sent back to ready queue to P1 process. So here P1 is forcefully stopped. So what is non-preemptive? It is opposite to preemptive scheduling. So once a process came and the ready queue, P1 came and it is taking CPU, means it went to running P1. Now it is P1 is executing, means it is, we can't forcefully stop this P1 process. So in that preemptive, forcefully we can stop, and that non-preemptive, forcefully we can't stop. That is the difference between preemptive and non-preemptive. So coming to preemptive, and that preemptive scheduling we are having some types, that is first one is SRTF, second one is priority. Next, coming to non-preemptive. Non-preemptive scheduling. First one is FCFS. Second one is HJF and multi-level scheduling. That preemptive scheduling, SRTF, priority, and one more is round robin. SRTF means shortest remaining time first, priority scheduling, and FCFS means that is first come first serve, and SJF means that is shortest job first. Okay, so today we are learning about FCFS. Yes, what is FCFS? Scheduling algorithm. FCFS means that is first come first serve. Okay, so which process came first, that process will be executing first. Okay, which process came first, that process will be executing first. Here we are taking numerical example for FCFS. So what is the numerical example we are taking means, here we are taking some processes we are taking here, and arrival time, AT means that is arrival time. Next we are taking here BT, that is burst time, TAT, that is turnaround time, and WT, that is waiting time. Yes, here processes we are taking here P0, P1 and P2, okay, and P3. 4 processes I am taking here, and arrival time I am taking here 0, 1, 3, 2. Okay, so next burst time 2, 4, 3 and 4. So FCFS means first process which came, that will be executing first. FCFS is the non-preemptive scheduling, means once the process came, it will be executing, it won't give the, means it won't release the CPU. Okay, so here coming to here, first P0 came, that is arrival time is 0. So arrival time means when it came, what is the time it came. Next burst time means here burst time we have taken 2 milliseconds, and turnaround time, waiting time. So burst time means how much CPU will take to complete that process. So here we have taken that is 2 milliseconds. So first process, that is P0, I am taking here Gantt chart I am taking here. So Gantt chart, what it will be do means, it will be representing the graphical representation here. Here first P0 I am taking, P0 it came what time, 0 milliseconds it came. So when it will be completing, as burst time is 2, it is taking 2 milliseconds to complete the P0. Next P1 came, at what time it will came, already it came at millisecond, that is 1 millisecond it came, and it will be completing within 4 millisecond. Next P1 came, and it will be completing in 4 millisecond, that is 2 millisecond within P0 completed, that is 2 plus 4, 6, means P1 will be completing in 6 milliseconds. Next coming to P2, P2 arrival time is 3, but it will complete it in 3 milliseconds. So that is 6 plus 3, 9. Next, 4. P3 came at 2 milliseconds. It will be completing. Then 4, that is 9 plus 4, that is 13. Means P0 will be completing in 2 milliseconds and P1 will be completing in 6 milliseconds and P2 is completing in 9 milliseconds and P3 is completing in 13 milliseconds. So here we need to take one more thing, that is completion time. Okay, completion time we have to take, that is P0 is the 2 and P1 is the 6, P2 is the 9 and P3 is the 30. So how to find out the turnaround time? Turnaround time we have to find out by using completion time minus arrival time. So waiting time we have to find out by using the formula, that is turnaround time minus completion time. So here CT, that is completion time. What is the P0 completion time? That is 2 minus 0, that is 2. Next CT minus 80, that is P1's 6 minus 1, that is 5, 9 minus 3, that is 6, 13 minus 2, that is 11. Next waiting time means turnaround time minus completion time, that is 2 minus 2, that is 0, 6 minus 5, that is 1, 9 minus 6, that is 3, 13 minus 11, that is 2. FCFS, that is first come first serve scheduling algorithm. FCFS means which process came first, that process will be executing first. So here we are taking one numerical, how to calculate the FCFS. So here we are taking processes and arrival time, burst time, turnaround time and waiting time. So processes I am taking here P0, P1, P2 and P3. Next AT means that is arrival time, BT that is burst time, CT that is completion time, TAT that is turnaround time, and next we have to find out what is waiting time. Okay, why we have to find out turnaround time, waiting time means which process means which scheduling algorithm is the best, we have to know by knowing turnaround time and waiting time. If you are getting average turnaround time and average waiting time is less, means that scheduling algorithm is the best scheduling algorithm. So here I am taking arrival time 0, 1, 2, 3 and burst time I am taking 4, 3, 2, 1. So here arrival time means when that process came to the ready queue, and burst time means CPU how much it will take to complete that process. So here P0 is taking 4 milliseconds and 4 milliseconds it will be completion its execution. P1 is taking 3 milliseconds, that is 3 milliseconds it will be completing, and P2 is taking 2 milliseconds, it will be completing in 2 milliseconds. So here we are taking Gantt chart to calculate this FCFS scheduling algorithm. So here I am using Gantt chart for graphical representation. By using this Gantt chart we can easily solve this problem. Okay, so first we have to know what is the arrival time of P0, that is 0, P0 and it will be completing within 4 milliseconds. We have to write down in right side. Next P1 arrival time is 1, means after 1 only it came, and it will be completing within 3 milliseconds. 4 plus 3, that is 7. Next P2 came at 2 milliseconds and it will be completing within 2 milliseconds. 10 plus 2, that is 9, and P3 9 plus 1, that is 10. Okay. So completion time is, this is the completion time. P0 completion time is 4, P1 completion time is 7, P2 completion time is 9, and P3 completion time is 10. So P0 is 4, 7, 9 and 10. Yes, how to find out turnaround time? Turnaround time formula is completion time minus arrival time. So completion time is 4, that is arrival time is 0 of P0. 4 minus 0, that is 4. Next 7 minus 1, that is 6. P2's 9 minus 2, that is 7. 10 minus 3, that is 7. Next waiting time. How to find out the waiting time is turnaround time minus burst time. So turnaround time we got, burst time is 4. Okay. P0 turnaround time is 4 and burst time is 4, that is 0 millisecond. Yes, P0 has been not waited for CPU. Why? Because it is at 0 millisecond it came. So here waiting time we got, that is 0. Next 6 minus 3, that is 3. 7 minus 2, that is 5. 7 minus 1, that is 6. Okay. So this is the turnaround time and this is waiting time of FCFS. Okay. Next we will discuss about shortest job first, that is SJF. Shortest job first. So here, which process burst time is less, that process will be executing first. So what is the criteria here? Burst time. So which type of mode means, which type of scheduling algorithm means, it is a non-preemptive scheduling algorithm. Yes, we already discussed that. What is non-preemptive scheduling algorithm? Yes, what is non-preemptive scheduling algorithm? Once the process came to the CPU means it will be executing successfully, then only it will release the CPU. So same here, I am taking numerical example to find out how to SJF will be executing. So here also we have to find out completion time, turnaround time and burst time. First we have to find out completion time. So process AT is arrival time, PT is burst time, completion time, turnaround time and waiting time. So first we have to take how many processes are there. P0, P1, P2 and P3. 4 processes we are having on CPU. These 4 processes are executing. So on arrival time we have to take randomly 0, 1, 3, that is 1 I am taking here again. Burst time, that is 2, 3, 4 and 2. Okay. So burst time means already we know that how much time it will take to complete that process. So same here also I am taking one Gantt chart to solve the problem. easily. First P naught came. Okay, P naught came at arrival time, that is 0 millisecond. Okay, and it will be completing within 2 milliseconds. Okay, completion time is 2. Next P1 came at 1 milliseconds. Okay, and it will be completing within 3 milliseconds. So 1 millisecond means P naught is executing, P1 already came here. Okay, so P1 is waiting for the CPU here. Next P1 will be executing here, that is P1 will be executing within 3 milliseconds. So here it is a non-preemptive scheduling algorithm. Why? Because it is not releasing the CPU till it will be execute. So next T2. T2 our burst time is 4, that is 2 plus, that is 3 plus 4, 7. P3 burst time is 2, 7 plus 2, that is 9. So completion time is, this one is the completion time. P0 completion time is 2, P1 completion time is 3, P2 completion time is 7, and P3 completion time is 9. 2, 3, 7, 9. Okay, so then we have to find out the turnaround time, TAT, that is formula is completion time minus arrival time. Next WT, waiting time, formula is turnaround time minus burst time. So here turnaround time means completion time minus arrival time, that is completion time is P0 is 2 and arrival time is 0. 2 minus 0, that is 2, that is 3 minus 1. P1 turnaround time is 3 minus 1, that is 2. 7 minus 3, that is 4. 9 minus 1, that is 8. Next waiting time. So turnaround time 2 minus this turnaround time minus burst time, that is waiting time. 2 minus 2, that is 0. Okay. Next 2 minus 3, that is 1. 4 minus 4, that is 0, and 8 minus 2, that is 6. This is the turnaround time, waiting time of shortest job first. Thank you. So next we will learn about round robin scheduling algorithm. Yes, what is round robin scheduling algorithm? Here we are taking time quantum. Based on this time quantum, process will be executing. So here if your time quantum is taking 2 milliseconds means this CPU will be given 2 milliseconds for every process. So here we are taking same, we are taking here numerical example to solve the round robin problem. So here we are taking some processes. So I am taking here P0, P1, P2 and P3. Okay. So P0, P1, P2, every process will be taken 2 milliseconds. So here what is happening in round robin means, here we are taking ready, queue and running. Two queues we are taking here, and first that will be coming, P0 will be coming in ready queue and it will be assigning to running queue. So how much time P0 will be executing means how much time quantum will be there, that much time only it will be executing, means P0 will be taking only 2 milliseconds. then P naught again it will be go to the ready queue. Okay, next again P1 will be coming here, and P1 will, how much time it will take to execute means only it will take how much time quantum will be there, it will take that much time, means P1 is also taking 2 milliseconds. Again P1 is also going to ready queue. Okay, P0 also gone and P1 also gone. Next P3, sorry, P2 also came to running state here, and P2 also it will be executing only 2 milliseconds. Again it will be go to the ready queue. Like this every process will be executing only 2 milliseconds. So here we have to take arrival time, burst time, and we have to find out completion time, turnaround time, and waiting time. So here arrival time 0, 1, 2, 3. Okay, burst time I am taking 4, 3, 2, 1. Okay, so here first process, so here we have to take here same like Gantt chart I am taking here to understand very well. P0 will be coming in 0th millisecond and it will be completing 4 milliseconds. So here time quantum is 2 milliseconds. It will be P0 will be given only 2. Okay, next coming to here P1 came and P1, hence here we have to first time is 4, that is 4 minus 2, that is having 2 milliseconds. Again we have to do the minus here, 3 minus 2, that is 1. So here it is also taking 2, 2 plus 2, that is 4. Okay, next it will also take 2 millisecond, that is 0, means P2 has been totally executed. That is minus 2 minus 2, that is 0. That burst time is 2, 4 plus 2, 6. P3 came at 3 millisecond arrival time and burst time is 1, means only it will take total time quantum is 2 millisecond, but it only it will take 1 millisecond. 6 plus 1, that is 7. So which process has been completed here? P2 has been completed, P3 has been completed. Again the CPU will be assigned to P0. Okay, so P0 it is having 2 millisecond, that is 2 minus 2, 0. So again P0 will be executing, that is 2, 7 plus 2, 9. Again P1 will be executing, only it is having 1 millisecond, so it will be also executing here. So here completion time of P0 is, here it is 2 and here it is 9. So which time we have to take here, which is having last, that we have to take completion time here. Next coming to P1. P1 how much time it will take in, that is 10 millisecond. Next coming to P2. P2 how much it will be completed, 6. P3 that is 7 millisecond it has been taken to complete the process. Same turnaround time formula is completion time minus arrival time. Waiting time formula is turnaround time minus burst time. So completion time how much, that is 9. 9 minus arrival time is 0, that is 9. 10 minus 1, 9. 6 minus 2, 4. 7 minus 3, that is 4. Waiting time how much, turnaround time minus burst time, that is 9 minus 4, 5, that is 9 minus 3, 6. 4 minus 2 is 2, 4 minus 1 is 3. So this is a round robin scheduling algorithm. If you are using round robin scheduling algorithm, means it is the best algorithm. Why? Because every process is giving some time quantum, so every process is executing here. So today we have discussed about that FCFS, SJF and round robin scheduling algorithms. Thank you.